Hello world, my name is Shithij, this is the coding tree, and today we're talking about loops. We're talking about loops. We're talking about loops. Where we left off last time, we were able to use if statements to our advantage in facilitating the decision making within computers. But our programs still lack something. Let's look at the last program we wrote in the previous video. It took a number, and then checked if it was positive, negative, or zero. The program compiles, the program runs, and the program does what it's intended to do. It checks if a number is positive, negative, or zero. But then what's the problem with it? Well, the problem is that it only runs once. What if the user wanted to input multiple things? Then each time they would have to run the program again and again and again? That doesn't seem like a good solution. That's where loops hold their relevance. Okay, being honest, for this type of program, it isn't that big of a deal. But repetition is key when several other types of programs, and it will for sure come into play in any other future program you're going to write. To understand loops to their fullest extent, let's work backwards on this one. Here is a program that simply loops through the numbers 1 through 100 and prints each one of them out to the console. The first line is for I in range, parentheses, 1 to 101, closing parentheses. Let's break the statement down. The first word in the statement is for, which essentially tells the compiler that we're about to write a for loop, one of two types of loops in Python. The next word, or I guess letter that we need to pay attention to is the letter I. I essentially is a variable that we create inside of the for loop. Note that the variable only exists within the context of the for loop and not outside. So what I does is it gets assigned every single value from 1 to 100 on each iteration or run of the program, which means that it gets assigned those values and then prints them out as per the next line. The next word is in. In is a key word in Python, but you don't need to focus on that just yet. You just need to understand that in serves two functions. The first one I'm not going to go over just yet, but the second one is just for loops. In serves the function of being in for loops and serving as a keyword that ties I and the range function together. The final phrase that we need to pay attention to is the phrase range, open parentheses, 1, 101, closing parentheses. This is another built-in function in Python. And what it essentially does is give us a set of numbers from the first value to the second value. Note that the first value is inclusive and the second value is exclusive. Remember how we said that we wanted to write a program that loops through 1 to 100 and prints those numbers out? Well, that's why we write 101 instead of 100 for the second number, because 101 is 1 greater than 100, and since it's exclusive, that means that 101 won't be printed and 100 will be. Similar in spirit to if statements, there is a colon at the end of the for loop. Why? Well, same reason. At the very following lines that have indents before them are going to be the ones inside of the for loop, which means that they are going to be the lines that are run X number of times, whatever the for loop specifies. So right off the bat, we can see one key strength of for loops. Instead of writing 100 lines of code that are just print 1, 2, 3, 4, 5, 6, 7, etc., we can just write 2 lines that loop through 1 to 100 and then print all of that down. So that's why for loops are so efficient, because they allow programmers to write more readable, maintainable, and concise code. But here we run into one more problem. Our program is kind of stupid. Why? Well, again, we have the problem of dynamism. Our program simply isn't dynamic. It just prints numbers 1 through 100 again and again. That's all it knows how to do. But let's fix that. Now note that not having dynamism is not always a bad thing, but at this such low level, it does become a bad thing when we can't write any more complex programs than what we can write without dynamism. So let's work on fixing that. Now you're gonna write a program that takes input from the user, and then loops through until that upper bound that the user specifies. It loops all the way through that number and prints all of those numbers out. So it's essentially the same as the previous program, except we're using a loop to ensure that we can print all of the numbers that the user specifies, not just 1 through 100. So it could be 1 through 10 or 1 through a million. Make sure in writing this program that you remember what parts of the range function are inclusive and exclusive. Now pause the video, write the program, and come back. Alright, let's run through this script. So let's look at the first line of code, which we've actually had to modify from before to make sure our program compiles. Why? Our old method of taking input simply won't work. That's because of the way that input is taken in Python. Remember data types? Yep, they're relevant right now. I said that they were going to be relevant in Python even, and yes, they are right now. Because we simply can't have a string be an input to the range function. Because the range function wants an integer. So that essentially causes the error that we see. Because the range function wants an integer, we have to adapt to that. Let's first see what the error is. Right now, we're debugging our first program. That's a big deal because debugging is a big part of computer science. The error says that you can only concatenate string to string and not int. This means that we're passing in a string when we need to pass an int. Because we're passing a string in, the program assumes that we're trying to concatenate. Remember that notion of combining two strings rather than add. So to fix that, we call the function int, and we wrap the input inside of int. Why do we do that? Well, int essentially does something that transfers the type to an integer from a string. What it does is it casts, what's known as casting, when it changes the type of a variable or a piece of data. As we see here, after input, we get some type of input from the user in the form of a string, then we convert it to an integer. This allows us to use it inside of the for loop, which is essentially the goal in the long run. Another thing you may notice is the added string inside of the input parentheses. Why do we add this? Well, because of the fact that in these parentheses, we can pass in another condition in the input function. This condition simply prints that line of code out of the console right before we take input. This is essentially for the user's experience. Because of this, we're able to make sure that the user knows what he's trying to, what the compiler wants from him, which is to type in a number. Again, it's okay if you didn't get that and have to look at the answer. Computer science is about experimentation and exploration. It's okay if you make a mistake in that regard, just pick back up and continue. Debugging is a big deal in computer science, and today was your first experience with that, so it's okay if you made a mistake. The for loop is essentially the same as before. First word is obviously for, then we declare our variable called I. Note that this could be any name that you choose, but most programmers prefer I. Then we have our keyword in, and then we have our word range. This range function call is slightly different than before. Here we have range parentheses 1 comma x, x being the input, plus 1. Recall that the last number in the range function call is exclusive, which means that we don't include that last number. That's why we have to add 1 so that we do include the number that the user specified, because otherwise our program would just fall one number short. As our last line of code, we obviously have the print statement, which obviously just prints out the number that the I is currently set to in the current iteration. This program shows us the secondary strength of for loops. It can be run an unknown amount of times. Why is that important? Well, let's say we did want to write a program without using that for loop that printed the print statements the exact amount of times that the user specifies. We simply cannot do that because numbers are infinite. So even if you had the fastest computer in the world that could handle a number like, I don't know, 3 billion, it would still take over 6 billion lines of code, assuming you're using if statements, to write a program like that without a loop. We can't predict ahead of time what the user is going to say. That's why we use a for loop and set it so that we only repeat the exact amount of times that the user specifies. This allows us to write programs that are interactive with the user, essentially a key component in computer science.